Right, today's video is about reballing chipsets. I'll be reballing a NVIDIA chipset here. Okay, part number is G86-630-A2. So I'll be reballing this today. The tools I'll be using, first of all, is the reballing jig Hunton HT90, which is this. Stencil is already mounted. Quite obviously the chipset itself. Solder ball 0.5mm. Original goot wick. And just be aware, you can buy cheap, crappy, fake goot wick off the internet, off eBay. So be careful when you're buying this stuff. I mean, it's no harm buying this stuff. You know, most of the time it'll get the job done for you, but they're fake. I'll be using a preheater made by Tenma. Rosin flux. I'll talk you through why I'm using this during the video. Amtech flux LF4300, and again, you can use them even after the expiry date. Look, it's 2012, it's expired. As I said on my previous video, this is not baby food, so as long as you keep it refrigerated below room temperature in the region of probably about 10 degrees Celsius, you're okay. The flux won't go off. I have a little microscope set up here, USB microscope set up here. And what else? Yeah, of course, Metcal MX5000 soldering station is what I will be using today, so I'll just quickly show you. That's on my bench here, and this tip is something I thoroughly enjoy using. Very nice to use for cleaning and things like that. The part number for this, for the Metcal MX5000 series, the cartridge number I should say, is SMTC-060. So that is SMTC 060. So that's what I'm going to be using. So let me just switch the tip over. I mean, I'm a big fan of Metcal in the sense that the amount of sort of the stuff that they produce. This is a high quality soldering station. I cannot dispute the soldering station. You know, I've seen Weller, I've seen many other sort of JBC, whatever, so on and so forth. But my preference is the Metcal MX 5000 series. End of discussion, basically. I mean, I've over the years I've bought enormous amount of cartridges. I mean, there's probably, look, the full pack. I probably have roughly about 40 different 40 cartridges plus, 40 plus, I would say, with various sort of shape, tip and shape and sizes and things like that. So anyway, getting back onto the reballing side of it, first thing first is I'm going to use a different jig for cleaning. So I have two jigs. One I use for reballing and one I use for sort of cleaning. So this is my cleaning jig and this is my reballing jig. Okay, so let's get cracking on with it. I'm going to turn the extractor fan on. Please forgive me, there will be a background noise during the process of me cleaning the BGA chipset. So here we go. And as always, before you rework, start any sort of soldering work and things like that, first thing first is protective. So wear gloves, and secondly and most importantly, you must have a fume extractor. So what I'm going to do now is I'm going to place the chip on top of this jig, apply flux, okay. Now let's move over to the microscope setup. and see if you can see what I can see. I may consider sort of lowering this a little bit more so we can have a better view. Let's see if I can zoom in. Okay, and I think this is as good as what we're going to get. Let me just sort of... Yes, okay, this is as good as what we're going to get. I'm going to bring down my extractor fan here to suck up all the fume. Power on the Metcal. Copper braid. And get on with the cleaning process. But before doing that, hence, I'm going to apply a bit of leaded solder. And just gently go over the surface. Very gently. A couple of times. And this should do the magic trick. Let me clean the tip. And now I'm going to use copper braid, clean off the surface of the pads from the BGA chip, nice and gently, just a couple of passes and you're good to go. Now the thing to remember is don't press down, do not press down on the actual tip of your soldering iron. And sort of pushing against the pads, because by doing so you may lift the pads, so be careful. All you're doing is just gentle hover. So look, I mean, for instance, just a gentle hover like this, so you're not pressing down on it, but at the same time you've got enough pressure so that you're moving the copper braid along the tip of your soldering iron. And that's it. It's as easy as that. So as I said, make sure don't press down and start sort of ripping out the pads. It's not clean. Let me sort of wet my sponge for the thingy, because it's not clean as I would like it to be. The tip of the soldering cartridge. That's better. Keep the cartridge clean and tinned effectively means that longer life expectancy of the tip itself. Okay, so let's move on to the next process. It's cleaning. I'm using 100% or 99.9% IPA. So we're going to get rid of the excess flocks and the leftover. Turn the extractor fan off because that's quite annoying. I don't need this for now. So you can go and rest. Right, by cleaning with this, you may leave, it's cotton bud what we're using, you may leave small signs of, or small pieces of fibre on the chip. So what I tend to do is I use a toothbrush. This is what I use. I would recommend to people. Just go around a couple of times like that. Let me get the camera a bit closer and see if you can. Yeah, it's because of the light, you're not going to see anything. Trust me. Okay, so let's get this. Well, I'm going to clean this after. Let's clean the chip. Bit more IPA. I think on a final inspection, I think okay, we're okay. Yep. So let's place this onto the reballing jig. Okay, so that's placed firmly tight the jig itself. Okay, now I'll be placing the stencil, and the next stage is to sort of align the stencil with the holes with the pads on the BGA chip. So let's do that. Sorry, didn't see that. Didn't even see this. Reduce the light. That will completely turn the thing off. Okay, I think that's much better. So yep, as you can see that the stencil is lined up. Okay, yep, I'm happy with that. So I'll tighten the screws now. The Allen key sort of screw, and there's 4 screws on the actual jig itself, just to sort of hold the stencil in place. Okay. I mean, direct heat is cheaper to buy versus what I paid for these stencils, which is why I'm not buying another set. And secondly, it can be a little bit easier to work with, whereas with these, if you put too much flux on the chip, then the reballing can turn into an absolute nightmare. Rightio. Okay, so what I'm going to use now, the next step is to apply a bit of this flux. This is tacky flux. The whole idea of using a tacky flux is to sort of, when you drop the solder ball through the stencil, you want the solder ball to stay in place and stick to the pads, sort of a thing. So this is the whole idea of why I'm using this, because it's very tacky. Only a tiny amount. Put a little bit too much, but never mind. Not supposed to use my bare sort of hand, but I normally use a brush, which I can't find, and just spread it out evenly and let it sort of dry all by itself. Okay, so we're going to wait for it to dry off. In the meantime, I'm going to give the other stencil a quick clean. Oops, that's a dirty cotton bud. But you can bloody see what I'm doing due to the intensity of the thing. But I think that'll do for now. I can go back. Let's go back onto the other one. Leave this here so I can throw all the rubbish. Let's see if that's gone dry and sticky, which it has. Yep, it has. Okay, so now what I'm going to do is I'm going to put the jig back on. Well, hang on, I do apologise, hang on, I forgot to do something else. My apologies. Right, okay. Flux, the most important part of the job is this. I almost forgot to apply that on actually. And how much am I going to put on? Only a tiny amount. Only a tiny amount, like the size of a rice grain. Look. Size of a rice grain. That's all I'm going to use. Okay, and then I'm going to spread it out. Okay, and I'm quite happy with that. Give my hand a bit of a clean. Although I'm wearing gloves, I will be touching other things, my hot air station, the jig, and so on and so forth, and I do not want to sort of contaminate those, or if that's the right word I should be using. Okay, so let's put the jig back on. Turn the light down. Okay, beautiful. Now solder balls. The balls. Yes, the balls. And chuck some of them in there until I'm satisfied that that'll do. Yes, it's crappy 15 frames per second, whatever it is from the microscope. Let's put the excess solder balls back into the its container. Why waste them? Let me grab a toothpick so I can sort of drop the rest. Okay, get rid of that. There is one. Okay. Oh, you sick fuck. Okay. So I've lost two balls. You can see there's one here, one missing here, and one missing on the top. Okay, so how am I going to put them back on? I'm going to wet my tip of my cocktail stick with a bit of a flux, so I can grab a few solder balls from the container at the tub. But the issue with the issue with these sort of stencils, unfortunately, is that when you lift the stencil away from the jig, there's a good chance that you may lift a couple of solder balls, and that's what really annoys me. Whereas with the direct heat, that's all you need to do, and apply heat, good on you. But in terms of flux, as I said, do not use excessive amount of flux, because especially using these sort of stencils, it'll sort of bridge, the solder ball will bridge. It's like, I don't know how to explain this to yourself. When you put a lot of flux in, it's creating a flow, and it's sort of the surface tension, sort of, there's like an internal tension in the flux itself, sort of grabs the solder ball. So as soon as you apply heat, the solder ball and the flux become liquidous. It tends to, or activate, it tends to sort of grab and like a magnet, and it sort of grabs one solder ball to another sort of a thing. So you do see a lot of that when you apply quite a lot of flux. So as you've seen, that I've only applied a small proportion of flux to sort of do the reball process on this. So let's hope for the best and try and lift this up and see how many solder ball that I get lifted. So I can see two that have come up. And I'm just poking them back down with the thingy. I'm going to inspect the up the other side just to see if there is any sort of solder balls that have come with the thingy, and in all honesty there is two here. So I'm going to place them back, and you probably can't see. There you go, those two are missing. So again, just use the tip of the cocktail stick to pick him out of the stencil and put it back onto the chipset itself. Okay, I'll be cleaning this after. Right, so let's have a quick inspection. Let me increase the brightness on that and have a quick whiz through and see if there is anything that is misaligned. I'm going to do that off camera because my eye is better than this microscope. Okay, and also yes, there is 2 solder balls are bridged due to the some sort of a surface tension or whatever it was while I was lifting the stencil. And just for the sake of it, I'm going to drag this into my ultimate microscope and have a quick look and make sure that there's no bridging or anything, because they are very, very fine and small solder ball, which are 0.5 mil, so they are very, very, very small. Okay, the good thing about the Mecal, it's got a power save mode, and I think the lowest you can have is 15 minutes. After 15 minutes or no activity, the device goes on power save, which sort of turns off the it turns off the unit itself. Right, I'm just having a quick whiz through the ball, just make sure that there's nothing sort of bridged or no. I wish I can show you this. I absolutely wish that I can show you this, but unfortunately that's not going to happen. There is one ball that's literally quite next to one another, so I'm going to create a bit of space between the two. Okay, so I'm quite happy with that. Okay, there's a couple of more, but I'm quite happy with those. And one here. So as you can see that, well, you can't see, can you? Let me see if I can get an angle. Please, in the name of God. Vision engineering, sort yourselves out together and try and we're in 2016, and people are the technology is far in advance, and you know, you should be charging stupid amount of money for these microscopes. So the least you can do is sort of sort out with a decent camera on with these microscopes, sort of a thing. In the name of God, just get your act together and deal with it, or sack your designers and I'll come in and help you out with it. Sack him, throw him out like Apple did back a couple of years ago when they had a big flaw with one of the iPhones. I can't remember what it was, and some of the guys have been sacked. Sack him. You have to keep up with technology. Look how much of a trouble that I'm going through just to sort of line up a view on this thing. It's just absolutely friggin' shocking. Okay, so I think you can just about see. Let me see if I can edit the scene. Oh, go away. It's crap. The visibility is crap through the microscope, unfortunately, but that's as good as you're gonna get. Absolutely fucking crap. But take my word for it, guys. You know, it's a cracking piece of equipment. What you see is not even a 10% of what it is in real life. So I'm going to sort of stop this nonsense now. Just move on to doing what I was doing. Right, okay. So we're happy with all the solder balls have been in place. Fantastic. Now what I'm going to do is that can go back in its place. Now I'm going to use a preheater. You're probably wondering what the fucking hell you need a preheater for. You'll find out soon enough. Let me just lift this up. Up. Okay. In fact, I'm not going to lie. Am I going to be able to do that? I don't know. Should be able to. Rightio. Okay. Now, myself a paint tool like this, and I bet you can't see what I'm doing, can you? Can you, people? No, you can't. Okay, let's go on to the microscope view. Yeah, all you can see is just the preheater. Right, okay, I'm going to put this on here. But the whole idea is I'm going to try and build up a bit of a heat so that the chips sort of become hot. I'm going to set the hot plate to about, say, 200 degrees Celsius, and so I'm not sort of applying too much temperature on the surface of the pads and the solder. But let's just sort of crack on with this now. So I'm going to use this to sort of lift the chip and drop it onto the top of this thing. It's an aluminium thing, so I don't know what I can name it, but unfortunately guys, you're going to smack me because the visibility is absolutely friggin' crap. I think that's as good as you're going to get. Let me sort of reduce the it's because it's reflecting from the surface of that thing, so that's where the problem is. Okay, anyway, let's get a cracking on with this. I'm going to turn the preheater on, and I'm going to start off with the heat in temperature 100 degrees Celsius. Okay, let me sort of so this is what I'm doing. Let me just turn this light off so you can have a... This is what's happening. So the preheater at the bottom, I'm leaving that flat so that this piece of aluminium is going to get heated up. I'm going to set the temperature to about 150, say about 175, and let's go back onto the thingy. You might sort of see the flux activating. Not yet. No, not yet. And you can certainly see some solder balls are running in the center. This is why I think it's absolutely bullshit when you're using some of these this type of stencil. I'm going to take my chances and sort of leave it like that. Right, all I need to do now, I'm using a cheap hot air station now. I'm not going to turn the Metcal HCT 900 because it's very noisy, very noisy. So the temperature is set at 395 degrees Celsius, and I'm only going to be there for a short period of time. So here we go. I'm going to go with the and then you want to reduce the airflow, because what that'll do, if you increase the airflow to very high, that'll just push the solder ball and create a bridging. So now all I'm going to do is I'm going to hover over that, as soon as I see them becoming liquidous, I'm moving away. There we go, fantastic, done. Switch off the heater. I will need to turn the extractor fan on. Forgive me for the level of noise from the fan itself. Whenever you're using a preheater or a hot air station or whatever it is, just don't switch the device off completely. Let it cool down, let the element cool down, which is why the Metcal HCT, I give them thumbs up, because when the device sort of switches off, it sort of carries on running for about 2 minutes approximately, and by then the element should have cooled down, and it's just to sort of help the life expectancy of the prolong the correct word of the element itself. So here we are, this is it. I mean, reballing is done. So I don't think this was too difficult. Let me sort of move this because it's creating a lot of I'm going to leave the thingy running for a little bit longer. Trying to make sure that it cools down. This aluminium sheet is creating a lot of reflection, so let me zoom down onto the Bga chipset. Go closer. sure that the image is nice and clear. Okay, so there we go. All the chips are in place. Sorry, the solder ball chips, solder ball in place. And the final stage, which I sometimes do, is just ultrasonic the chip, and then you're ready for sort of rework attempt. So this is it really. Usually if I don't sort of ultrasonic it, I'd just literally clean it with IPA. And there's nothing wrong in doing with sort of cleaning it with that. I'll show you why. That can go off, the extractor fan go off. And what this does, this is quite a helpy tool actually, well, a toothbrush I should say. Sometimes you may find that the solder ball may look it's sort of made a contact with the pad, but as you're sort of moving, as you're cleaning, the solder ball will just flip out, which effectively means it's not sort of bonded with the pad. So one of the good reasons why I'm doing what I'm doing is sort of technically at the back of my mind sort of thinking, right, okay, let's see if any of them come off. I'm going to brush for a couple of more seconds and sort of see if any of those solder ball will just flip off. So let's have a final inspection. I need to sort the focus out, I think that this is as good as it's going to get. So there we go. So that's it really. As I said, you don't need to use a lot of flux. If you use a lot of flux, you're going to bump into a lot of problem. Please listen to me. You only need to use a small amount of flux, and sort of you don't necessarily need a preheater as well. I use it because it makes my life a lot easy. You know, by preheating the IC, you're already building. You know, you're already sort of preheating the chip itself to 100-150 degrees Celsius. As soon as you apply heat on the surface of the IC itself, boom, everything goes pretty well. So you know, I always sort of try and use one of them, but you know, if you don't have one, then you don't necessarily need to. But in terms of buying stencils, I'd probably recommend direct heat stencils rather over these, because if you're using too much flux, God help you, you will have a lot of problem reballing the chip and things like that. Maybe you know what I'm going to do? I'm going to show you actually what I'm on about. All right. So I'm going to. This is a. I think it's a dead chip. I'm not bothered about it. You know, if I take the solder off. So let's show you something actually. Let's show you something, because I may not get the chance to do this any other time. So let's show you something, guys. Okay. The result may differ if you're using solder paste and direct heat stencils, but if you're using these sort of things, do not use silly amount of flux. You will turn your job into an absolute nightmare. Just make sure it's in focus. Yep, that's better. Okay, so let's turn the hot soldering station on, extractor fan on, copper braid. Where's my copper braid gone? It's here. I'm going to apply a bit of flux to remove some of the solder balls. And again, when you're cleaning the pads, you do not need excessive amount of flux. And I say this to someone on the internet many times, but hell no, he doesn't give a shit about it. No names, by the way. So look, that's all. That's all you friggin' need. Okay, so again, I'll be using the Metcal soldering station. Let me sort of get the extractor fan a bit closer, because otherwise I will be inhaling those solder fumes. There's no doubt about that. I'll just drop my hot air station, it doesn't matter. Let me get in view. Come on. What I should have done, stupidly, is take excess solder off with the tip of the iron first before jumping into the with the copper braid. So that was my mistake for not thinking properly. Let's chop this off. Clean everything, and let's clean the tip of the soldering iron. Okay, that's nice and clean. That's how it should be. Go through one more pass. I normally go in a nice sort of a circular motion like this. Think about like buffing your car body. If you go in like this sort of a thing, you leave swirl marks. You can leave line, but you'll always see a sort of anybody that's doing a buffing. They'll go in this motion. Even the buffing machines will go in a rotating sort of a thing, not side by side. So I think the cleaning is much better if you sort of go in this rotation. Just imagine sort of being the Karate Kid. Right stroke, right stroke. I'm just messing about, guys. Just shut the crap and just get on with it, basically. Right, so that's done. Let's clean the surface. Probably just grab myself another cotton bud, and then, I mean, the whole idea of using the cotton bud is to sort of get rid of excess dirt from, well, the flux and the leftovers from the chipset. And what I'm going to do is, I'm not going to go through the full process of the reballing thing, but I'll demonstrate something to yourself very quickly by sort of applying a couple of solder balls onto the surface of the IC itself. If I can't do that, then I'll show you. I'll go through a full reballing process of the entire chip again and demonstrate what it is that I'm referring to when you put too much flux on. Okay, so let's take this off. Extractor fan will be turned off now. Hopefully I can turn it off. I dropped my nozzle for the hot air station, which I'm not very happy about, but it doesn't matter. It really doesn't matter. Right, okay. Interesting. Right, what should I do now? Should I sort of use this jig as it is and no, I'll tell you what, I don't need the jig because I'm not going to use the stencil, so we can put hell with that. Where's this aluminium thing gone? Okay, so what I'm going to do now is, ladies and gentlemen, clean this off with IPA. Yes, I know you're not focused properly, but that's this, because I don't need it to be focused now, but let me just sort of alright, okay, tell you what, come on. Is that better? Yes, it's indeed. It's better. Thank you. Okay, so what I'm going to do now is I'm going to use someone else's method. But before doing so, I need to apply some, oh, in fact, no, I'm going to do it in the center bit here. Okay, so put loads of flux. Leave that. I'm just only going to do it on the center here, just for demonstration purposes. So I think that's no, that's not enough. Okay, so that might be enough. Okay, so what I'm going to do is I'm going to grab a few solder balls from the in fact, I have a toothpick here out already, so let's crack on with the picking solder balls from the tray, and I'm going to go in there and grab a few more, maybe a couple of more. Okay, and now I'm going to apply, sort of line them up manually. Since I'm not using the stencil, it should have been a lot easier with the stencil, but unfortunately no, I've decided not to do that. So I'm going to it's not necessary to put that many ball to sort of demonstrate what it is that I'm trying to sort of do here. And on that note, I'm going to go into my ultimate microscope setup, because this is doing my fucking head in, creating a lot of eye strain, and I can barely see what's actually happening. So let's switch back onto the big boy here, move this out of the range, and come back to the big boy. Okay, now we're talking. I'm going to switch over to 10 times. Beautiful. Okay. It might suck at doing what I'm doing, but who cares? This is just a demonstration. Just want to line those solder balls perfectly. Okay, so what I'm going to do now is see if I can get you guys a quick glimpse. I'll try my best, but very unlikely I'm going to be successful. Any luck? No. Okay. No. Okay, that's all you're going to see, unfortunately. Okay, let's sort of jump back onto the microscope, and hopefully you can see all the solder balls. Let me sort of go a bit closer, just show you that all the solder balls are and as where they should be. Okay, come on, zoom. There we go. Okay, so I've tried my best to line them up. Let me sort of bring this over to the screen and see if I can sort of line them up a little bit better. So there's clearly space around the solder balls here. Okay, so let's jump it back onto the preheater again, which you don't have to use, but I have it, I use it, it helps me. I'm not exposing excessive amount of heat onto the chip, so the whole idea of using a preheater is to sort of minimize exposing too much heat onto the chip itself. And unfortunately, And unfortunately the hot preheater, there is that better? Is this better? Let me focus. Okay. This is shit, crap. But what do you expect for a cheap ass microscope? Right, so what we're going to do now is turn on the preheater, turn the I wish I can get you a better view of this. Actually, I wish I can do that. It's not going to happen. Maybe, you know what, maybe I'm going to try something different, because this is giving out way too much glare, so reflection sort of a thing. So yep, I think that's much better. Yep, that is much better. Okay, and that's about the settings. Okay, turn the preheater on. I do need to turn my extractor fan on because it was quite thingy before. There was a lot of fume. And then power on the hot air station. Again, you've got to reduce the thingy. Airflow, I set it to 4. Okay, and the flux is already activated because the temperature of the thingy is 100, and I'm going to shoot it up to 175. And then let me see if I can demonstrate what it is that. So watch those solder balls here on the top, for example. Them ones, watch them and see what happens. I bet it's not going to happen this time around, will it? No, it's not going to. Fucking mofo. Fucking motherfuckers. So it won't do it this time around then. Okay. Very bad demonstration. But shit doesn't happen when you want to sort of demonstrate it, unfortunately. So that's very sad. Very, very sad. Very, very sad. All the solder ball flew into place. So, but I've done it many times in the before. You're just going to have to take my word for it. As I said, reballing, when you're reballing an IC, you do not need excessive amount of flux. So that's it really. Hopefully I should be doing a video where I'm going to sort of strip down one of the BGA chipset and have a look at the real connection, real connection between the PCB and the die itself. I want to cut this BGA chipset to an extent where I can actually see the bumps, because that is one of the key and the fundamental failure of BGA IC. So I'm hoping to do that at some point. But in terms of as far as the reballing goes, this is what we're all. Sorry, let me just sort of switch. Yeah. So as far as reballing is concerned, this is how it's all done. It's not too difficult. Anything you do, it's all about confidence. So make sure you're confident in doing what you're doing. Make sure you have good tools to work with. If you have good tools to work with and you still can't do it, that means that you need sort of more training, or you're not good enough in doing what you're doing. So you need more practice. And in all honesty, believe me, I do things my way, you can do things your way. There's no perfect way of doing things. It's what sort of suits you and how you do and what you're comfortable with is what matters most. So I would strongly recommend that, you know, if you're learning anything, it doesn't have to be technology, it doesn't have to be graphic chip reballing, anything you want to do, you try and do it yourself, and that would be the best form of learning, sort of a thing, and stick to what works for you best. Don't sort of take advice from people. There's nothing wrong in taking advice from people, but once you know that a routine that works for you best, stick to that routine. Saying that, try and improve your routine as well at the same time. So it doesn't necessarily mean that, you know, you just sort of how should I say this, fuck it. So basically, anyway, that's it really. And if you've got any questions or concerns, I mean, just do sort of drop me a message below, and I'll try and help you out with it. But just one thing I'd like to, on a final note, I'd like to sort of mention to you guys is, when you're storing flux, please keep them in a refrigerator. I have one on the top here. Oops, shit, see, Tipex. Right, I have one here. There you go. This keeps all my flux, everything, and this is roughly about 8 degrees Celsius, 10 degrees Celsius this. So that's it. Oops, you've almost got me addressed there then. Yep, I would like to work in the dark. I don't sort of show my face, and do not sort of share my contact details with people. So I think I was going to clean the stencil and the jig, so maybe if you want a hand fire, I can do that. Leave the video running. That chip is a trash, so that can go back in the trash pile. And as always, clean. I've had this stencil jig for quite a while now, and it's just as good as new. Switch it off. You can. So there you go. Very little deposit. Like with anything, I thoroughly enjoy soldering. Soldering is something that I started as a hobby, and it's turned out to be a full-time sort of well, doing what I do turned out to be a full-time occupation for me now. So which is a good thing, and it's something that I sort of enjoy, which is why I have a stupid amount of collections of electronic equipments, which I will go through at some point when I have the time, with all the tools that I use, and what I use for what, and so on and so forth. Now that's my Hunton, so I don't want to mix it up. This is the good quality thing, and again there's solder flux at the back, so I need to clean that off as well. Back of the stencil itself, just give it a quick wipe. Normal flux, okay, so that can go back in its box. So HT 90 Hunton, made by Hunton, pretty good jig. They're pretty much the same thing, you know, but I always stick to branded products, because I you know, you're confident that things are right, and things are going to be okay, except Samsung and Apple. And I'm not going to sort of accept Samsung for Note 7 and Apple for iPhone 7. What a fucking bullshit. There's virtually no difference in terms of the body for the iPhone 7. Now, I used to be a iPhone fan, big iPhone fan, until I realised that iPhone is nothing but a fucking rip-off. The highest iPhone 7 Plus is retailing the highest capacity, I think 256 gigabyte, anything in the region of £1,000 to £1,100. I think it's about 1,000 to 1,100 if I'm not mistaken. So I then decided, right, okay, suck it, I'm not fucking buying, I'm going to go for a Samsung S7 Edge. Okay, beautiful phone, really like it. A lot of features, packed with features I should say, versus the crappy, shitty iPhone. There's always Bluetooth restrictions. and going to give it a quick clean with IPA. I've got 2 tubs of IPA here. So anyway, going back onto Samsung, why I think Samsung is shit is because of the Note 7 issue. But saying that, out of the 2, if I had no choice but to choose between Samsung and iPhone, I'd stick to Samsung. Particularly because of there's only a small improvements every year with iPhones, and secondly, the overprice. The price tag is huge. So no, thank you, iPhone. Right, I think the cleaning's done. Everything's done. This is going to go back in its place, and I'm going to put everything back together how it was originally into my box, and I think that's it. We're on Friday now, so have a good weekend, everyone around the world. If it's the same sort of time if it's the same day, Friday, then tomorrow Saturday. Otherwise, everybody in the UK, all the best. Have a good weekend, and I'll speak to you on the next video.